Hello everyone and welcome back to Diksha Karnataka YouTube channel. So I know many of you are requesting me for this video. So today I have brought this lecture to all of you. Maybe you are currently studying in first year or second year and you are wondering why I am not able to understand any concept that is being taught in my class. Then you are at the right place. Today we are going to discuss the basic fundamental mathematics that is required to understand physics in detail. It will going to be a 4-part video, 4-part lecture. Do not miss a single lecture throughout the course. So please be seated, take a pen, take a paper and please note down whatever I am going to say throughout this lecture. So the first lecture, first topic of this basic mathematics of physics is trigonometry. Okay, trigonometry we are going to start today and we will discuss whatever all you are going to need for your physics. So not only for your physics, maybe it will help you to understand maybe mathematics as well. And all these fundamental concepts, there are some gaps that you may have during your previous classes because you missed some classes due to COVID or some other reason you have not understood the concept properly. Now when you came to first year is gone, you have not understood a single line, right? Then you went to second year, now you are still struggling to understand what is happening in the class. I am not able to understand. For that basic things, trigonometry, okay, then there will be some geometry as well, some algebra as well, some calculus as well, some graphs as well. These all important topics we are going to discuss throughout this series, basic mathematics for physics. So first topic of today is trigonometry, okay, and trigonometry we will start with basics. Okay, this will be very basics. If you have learned or if you remember them, please try to recall as I am going through this. The first topic that we will start today is Pythagoras theorem. We will start from the basics. Okay, what is Pythagoras theorem? Pythagoras theorem talks about a right angle triangle where one angle is right angled. Okay, now if these two sides adjacent to the right angle are say A and B, and this side, the opposite side, it is called hypotenuse. Hypotenuse is h, then we can write that h square equals to a square plus b square. Okay, the very important that you should remember these values. Okay, now if any a and b are given, you can correspondingly calculate h. If only a and h are given, you can calculate b by substituting the value and then doing the h square minus a square. Sometimes we write h equals to square root of a square plus b square. Okay, very important, very important. If you know two sides, you can find the third side. That is the basic thing about Pythagoras theorem. Pythagoras theorem is only this much, nothing else, not much. You can apply this to find calculations for mathematics, but we will see how we can apply this in physics as well. Next, ratio of angles, very important. Ratio of angles, there are mainly 3 types of ratio of angles and then they are inverse. Okay, so for we in physics only 3 types of angles are 99% cases 3 types of angles are all that is needed, but maybe in some cases you will need to learn the inverse of it. I will just briefly explain the inverse of it as well, so don't worry about that. So suppose we have a right angle triangle, this side is A, this side is B, okay, and this side is say H. Now if this angle is given, if this angle is given to you, okay, if remember this, all the ratios depends on which angle is given to you. If this angle is given to you, based on this there are 3 ratios. First is sin theta. Yes, ratio means these values are called ratios. Sin theta, what is sin theta? Sin theta is, some people have curly brown hair turned permanently black. So I will say that equation as well. to remember what will be the values for sin theta, what will be the values for cos theta. This is a mnemonic. You can remember. Sum stands for sine, P stands for perpendicular, A stands for hypotenuse. So if this is the angle, what is perpendicular? This is perpendicular. So we can write A by H. H is the hypotenuse, right? Some books, some cases you have may have represented that using P as well, but does not matter as long as you remember what is the value for that, what is perpendicular, what is base. So if this is the angle given, then the adjacent side is called base and the perpendicular side is called perpendicular. Okay, whatever is on the other side, and this is hypotenuse, always constant. This will change. I will show you how it will change based on the angle given. That's why I have mentioned A and B. Now cos theta is curly brown hair. You should remember this mnemonic. It is very important. Some people have, sum stands for sine, P stands for perpendicular, H stands for hypotenuse. Curly brown hair. Curly means cos, B for base. Base is B. Hair stands for hypotenuse. Okay. Turned permanently black. So you have understood what we are talking about. Turned means tan theta. Okay, permanently black. So P by B. Understood? So this is the simple thing that you can remember. Now instead of giving this, what was given to you is this angle phi. Say this angle is given phi. Okay, this was your A, this was your B, this was your H. Now how can we write the same thing? Sin phi, cos phi and tan phi. How can we write this? So for that, now the perpendicular and base will be exchanged. So if this is phi, that means the perpendicular will be the opposite side, that is opposite to the angle, that is this B. So B by H. H will remain same. Cos phi is the adjacent side. Remember that cos is always adjacent. And tan is perpendicular by base. So B by A. Okay, understood? One more thing, you can write tan as ratio of sine by cos. I am not writing the angle, there will be theta or phi, whatever it is. So you can write that angle of that is tan can be represented by sine by cos. Now there are three inverse I talked about. What are the inverses? Inverses are cosec. Cosec is inverse of sine, so that is basically 1 by sine. Sec is 1 by cos, and cot is 1 by tan. If you can remember all the sine, cos and tan, then inverse is always just reverse. Okay, no rocket science, not any difficulty here. So far I have understand that you have understood the concept. So we will move forward and remember this, it will help you in future. Okay, remember this, it will very important and it will help you. If you have any other mnemonic that you already remember, that is also fine, but since childhood I used to remember this story, this poem kind of thing, and it is still with me. Okay, let's move on and let's see the values for these ratios for some common angles. These are the very common angles mostly used in most of the calculations in our day-to-day life. For any calculation, any numerical that you are solving, these angles are the most common. Now how can we find or remember the values? Either you can remember all the values, you write, you practice, you remember, that is fine, but if you don't remember, then how you can recall them? So for that we will start with sine, that is our first ratio. Okay, and the first angle is 0, so we will start with 0. Okay, then we will continue using integers. What is the next integer of 0? 1, then 2, then 3, then 4. So we have reached our last point. Now what is the biggest number here? Biggest number is 4. So we will divide everything with 4. We will divide everything with 4. Okay, we will divide everything with 4. Okay, clear? Any doubt? Any questions? Now what we will do, we will take a square root of everything. We will take square root of everything. Okay, now tell me what are the values. 0 by 4 is 0 by 4 means 0. Square root is, yes, 0. Square root of 1 by 4. Square root of 1 by 4 means square root of 1 divided by square root of 4. Square root of 1 is 1. Square root of 4 is 2. Yes, correct. Now what is 45 degree? 2 by 4. So there will be a cancel. 1, 2. What will be the value? 1 by root 2. Right? Now what will be this value? Square root of 3. We cannot do anything about that. And square root of 4, that is 2. Now 4 by 4 is cancel everything 1. 1. Square root of 1 is 1. So we have calculated the values for sine. Next, we will inverse this from here to here to find the cos value. So we will start with 1, then root 3 by 2, then 1 by root 2. So they are coinciding with each other. This will come here half and this will come here 0. Okay. So sine 0 is 0, cos 90 is 0. Okay. Now how to find tan? Tan we will divide sine by cos. We already know that sine by cos means 0 by 1. Anything divided by 0 divided by anything is 0 except 0. Now look at this. Half divided by root 3 by 2, that is 1 by root 3. 1 by root 2 divided by 1 by root 2, that is 1. Root 3 by 2 divided by half, that means root 3. And 1 divided by 0, this is not defined, so we will write undefined. Not infinity. This is not infinity. Okay, this is undefined. It is basically tending towards infinity, but the definition is not given. So we will write that as undefined. Next, ratio of angle to special angles. Now, so far whatever we have learned is for known angles 0, 30, 45, 60, 90. There are two special angles specifically for physics. This is common for mathematics, for physics. Everywhere you will find these values. You have to remember these values. If you can remember these values is very good. I will suggest you should write this table at least 2-3 times on your own so that you can understand and remember the values. And there are two special angles 37 and 53. How these angles arise? It arises because when the sides of a right angle triangle are 3, 4 and 5. Okay, so you can check they are satisfying Pythagoras theorem. 3 square plus 4 square is 25, square root of that is 5. So when the sides of a right angle triangle are in this order, the corresponding angles are, one of them will be 37, one of them will be 53. Now which one will be 37? The angle which is opposite to the smallest side. The angle which is opposite to the smallest side will be 37 degrees. And the angle which is opposite to the longest side, that will be 53 degrees. Now longest in the means these two sides, okay, not the hypotenuse. Hypotenuse will always be greater than the other two sides. Now if you add these two angles, if you add, there is something interesting. If you add these two angles, what you will get? You will get 90 degrees. So they are complementary angles. Okay, they are complementary angles. Now you have to remember, either you can remember this triangle and find cos sine values, or you can remember the values directly. That sine 37, tell me what is the value? What is the sine means? Sine means perpendicular by hypotenuse. So perpendicular is 3, hypotenuse is 5. Cos 37 degrees. Cos 37 degree will be 4 divided by 5. Right? And tan 37 degrees is sine by cos 3 by 4. Okay. Now tell me the values for 53 degree. Sine 53, what is the value? Sine 53 means now this will be base, this will be perpendicular. So perpendicular will be 4. So 4 by 5. Similarly, cos 53 will be 3 by 5 and tan 53 will be 4 by 3. Now if you see sine 53 and cos 37 are same. Cos 53 and sin 37 are same. Okay, this is different, they are just opposite. Okay, tan 53 and tan 37 are just opposite. Now, if you remember any one set, you can remember the other one by just reversing it. Okay, so if you remember sin 37, you can remember cos 53 as well. If you remember cos 53, you can remember sin 53 as well. So they are basically just reversing in order. So this is not very difficult, but in many numerical problems, JEE, NEET, in many cases these angles are very important. They ask questions directly where the angle is given in the value of 37 and 53, and they expect you to know these values because this comes from this specific case. Okay. So now let's move on. Degrees to radians. So far whatever values we have learned were in degrees. So degree means 30 degree, 40 degree, 50 degree, like that. Now there is another way of representing an angle, that is called radians. You may have seen the values given as pi by 4, pi by 2. Okay, now how can we convert a degree to radians, and what is the meaning of radians? Basically radians means it basically gives you the circle. Okay, now if we go around a circle halfway, then that is called pi radians. Half circle, pi radians is half circle, right? Full circle will be 2 pi radians, right? 2 pi radians. So 2 pi radians is full circle. Now tell me, what is the angle for full circle in degrees? So we start here, we start measuring 90 degrees, 180 degrees, 270 degrees, 360 degrees. So basically 2 pi radian, the symbol for radian is like this. We generally represent radian like this with a C in the top, is equal to 360 degrees. Okay, so 1 radian is equals to 360 divided by 2 pi, right? Or in the opposite, 1 degree equals to 2 pi by 360, or equals to pi by 180 radians, right? So whatever angle is given, if you multiply them by pi by 180, you will get the corresponding value for radian. So for example, 30 degrees is equal to how much radian? 30 multiplied by pi by 180. Okay, so you will cancel this, we will get pi by 6. So the table that we have seen previously, some cases they mention the values in radian, pi by 6, pi by 4, pi by 4 is 45 degree, okay, pi by 3 is 60 degrees, pi by 2 is 90 degrees, like that also given. Okay, and in physics, in many cases this is very handy, especially if you are learning waves, oscillations, or electromagnetic waves chapter. These values are very handy. Also solving numerical problems, this is also very handy because rotational motion also. So these values are given in terms of pi. So 2 pi radian means 1 rotation basically. So if something is given pi rpm, means it is rotating like that in that much degree in 1 second. Okay, so basically sometimes it is given so that it cancels out. Next, you understood? So this is the angle. It may be represented in a radian or it may be represented in a degree. Both are same. Okay, both are same representation, only values are different. Radians are given in terms of the path it traversed in a circle. Okay, degrees does not require a circle, but radians require a circle. Okay, now let's move on. One very important thing, arc length, radius and angle. Relationship between arc length, radius and angle. What is the meaning of arc length? If you take a part of a circle, okay, that is called arc length, say L. Okay, this arc length, this part is called arc length. This is basically not full circle but a part of a circle. Okay, and radius is the distance from the center, radius say r, okay, r, and if this angle is theta, then if we represent this angle in radians, then we can write L equals to r theta. This is a very useful formula. It is used in small angle approximation in many different cases. So just remember that this angle should be in radians. It is not expressed in degrees. That's why we have learned about radians. Now if we are applying to find this arc length, suppose in some problem it is given, it is rotating and it rotates to some after some time it reached here. What is the distance from the starting point, or what is the path it has traveled? So in that case you have to use, this is L, okay, this angle is theta in radians and radius is given r, then we know the formula L equals to r into theta. Now if the theta is very small, if the value of theta is very small, then in that case this curve length and this straight line distance, they are considered equal. In some cases we will apply that approximation as well. This is a special case where in general they are not same, but in some cases, for example, the radius is very high, okay, we are measuring something at a very distant object, okay, in that case this curved length and the straight line distance, they are basically same. We can take, if the angle theta is very small, okay, in degrees, minutes, very small value, then this distance and this distance can be considered same, okay. So that is also used in modern physics, modern astronomy as well, but we will not discuss right now. In some cases this is also considered as small angle approximation. Now the real small angle approximation is when theta is represented in radians and theta is very small, okay. So two conditions, theta expressed in radians and theta, value of theta is very small, then we can write sin theta approximately equals to theta. So only if it is expressed in radians, it is not valid for degree, okay, it is not valid for degree, it is only valid when the angle is expressed in radians. So I have seen people using directly degrees, that is not correct. So if the value is given say 0.1 degree, it is a small angle, agreed, but you cannot write sin 0.1 equals to 0.1, no, that is not correct. So what you have to do is, you have to convert this into radians, pi by 180. You can write this, this is correct. So basically what it is saying, that if you convert this degree angle into radian, then that corresponding value will be actually the value for sin theta, directly you can take. So if the angle is small, first you have to convert this into radians, then you can write that angle as theta, okay. So what you have to do, you have to convert the angle back to radians, then only you can use this approximation. Again cos theta will almost be equals to 1 and tan theta will almost be equals to theta, right. Tan is sin by cos, so basically theta by 1, so 1 theta, okay. So these are the three very important small angle approximation that we use from time to time, maybe to understand theory, to solve some theoretical problem, or while solving some numerical problems where theta value is given very small in degrees, but you have to convert that first into radians, then only you can use it. So be careful about that. I have seen people using directly in degrees, so don't do that, convert it into radians, then only you can apply this approximation. Next is some formulas, some addition formulas, some subtraction formulas for sine and cos. So sine alpha plus beta, so alpha, suppose we have two angles, sine alpha, alpha and beta, so we have two angles, say alpha and beta, okay. If we know the sin alpha and cos alpha for that, and sin beta and cos beta for that. Then while adding these two and writing the sin alpha plus beta together, we can write this is equals to sin alpha into cos beta plus cos alpha into sin beta. So basically sin cos, cos sin. Okay, sin alpha cos beta, cos alpha sin beta, sin cos, cos sin. So if you are having difficulty in memorizing that, just remember for sin it is sin cos, cos sin. Sin is always stays together. Sin is a family man. He always stays together with cos. He is friendly with cos. Sin minus in this case will be minus. Everything else is same. Okay, sin cos, cos sin. Now when it comes to cos, cos stays with only cos. I am cos, I will stay with cos. You are sin, you stay away from me. So cos alpha plus beta is cos alpha cos beta minus sin alpha sin beta. So he is saying I am cos, I will stay alone, you sin, you stay away from me, that is why this negative sign is coming. Okay, you stay away. Okay, now when you are doing the subtraction, you are trying to say okay stay away, then cos is saying okay you are also a part of my family, you get added to me now, but I will not share anything with you. So cos alpha cos beta, okay, sin alpha sin beta, but they are staying together with a plus sign, right. So when there is a minus, there will be a plus, when there will be a plus, there will be a minus. So you have to remember this particular, but cos will stay with cos, sin will stay with sin. And tan is also another important thing sometimes, but these four are the major things required. These two are not very important, but sometimes it comes for, especially if you are preparing for advanced level physics or some difficult JEE mains level questions, they can ask questions based on addition of alpha plus beta for tan as well. So, but I hope that if you are studying mathematics properly, this is very common in mathematics. May not be that much common in physics, but this is very common in mathematics, in differentiation, in substitution, integration. You do this kind of substitution a lot. Okay, x, y, okay, x, y you substitute with tan theta tan alpha, so that comes around tan alpha plus beta. Then you do the integration, right? You have done that, right? Substitution, this kind of substitution. Then yes. So this kind of substitution are very common in mathematics, not so much in physics, but at some time maybe it is coming handy. So you just remember that tan alpha plus tan beta. So if there is a plus, there will be minus tan alpha tan beta. If there is a minus, there will be plus. Otherwise on top it will be minus. So top will be same sign, bottom it will be opposite sign. That is a thing to remember. Okay, tan alpha plus tan beta divided by 1 minus tan alpha tan beta. Similarly, tan alpha minus beta equals to tan alpha minus tan beta divided by 1 plus tan alpha tan beta. Okay, understood? Clear? Now, double angle, these are also very important in physics. You have used this, those who are already in current second year, they can remember that we have used this in parabolic motion, that is projectile motion. Okay, these values come and then we divide it, right? So sin 2 theta is 2 sin theta cos theta, very important. Okay, sin 2 theta is 2 sin theta cos theta. So whenever you will see 2 sin theta cos theta, you can combine them to sin 2 theta. Okay, and cos 2 theta is cos square theta minus sin square theta. Very important, the common formula that you use is obviously sin square theta plus cos square theta. I have not mentioned that anywhere because I guess you already know that. So, but here it is opposite, cos square minus sin square. Okay, not sin square minus cos square. So it is cos square minus sin square. People get confused with this because here sin is first, so maybe here also sin is first. No, here cos, we are writing for cos, right? So cos has to be first. So cos square theta minus sin square theta. Okay, now few more formulas. It is also very handy sometimes that if you see 2 cos alpha cos beta. So 2 sin theta cos theta is 2 into sin theta into cos theta is sin 2 theta. But if this is not like that, if it is 2 cos theta cos beta, then we can write that as cos alpha minus beta plus cos alpha plus beta. Okay, similarly sin alpha sin beta is cos alpha minus beta and minus. So because sine is not very common with cos, so there will be a minus sign, cos alpha plus beta, but minus sign will be first, minus minus then plus. Similarly here minus first, plus plus, okay. And 2 sin alpha cos beta is sin alpha plus beta plus sin alpha minus beta. So you might say, sir, why you have not written cos alpha sin beta? It is nothing but, if you are saying, okay sir, what will be cos alpha sin beta? Can we write this like this, sin beta cos alpha? We can write it like this, right? And then we can use the same formula, sin beta plus alpha plus sin beta minus alpha. We can write this, right? So no, nothing different. So only one formula if you remember for sine, that is done. For cos you have to remember 2 formulas. For sine only one formula is sufficient. Next, quadrants, another very important, since we are talking about trigonometry, is very important. There are so suppose what is the quadrant? Quadrant means 1/4. Quad means 1/4. Quadrants means when you divide something with 4 parts, that is called quadrants. Each part is called quadrants, okay. So this is x axis, this is minus x axis, this is y axis, this is minus y axis, right? Now when both x and y are positive, that is called first quadrant, okay. First quadrants, I am writing first Q. This is, now if you move in the anti-clockwise direction, clock moves in this direction, so if you move in the anti-clockwise direction, this is second quadrant, and this is third quadrant, and this is fourth quadrant. Sometimes people confuse first, second, third, fourth. No, first, second, third, fourth. So basically what you have to do, you have to start like this, and then you have to move 90 degrees, right? You can remember this 90, 180, 270 and then 360. So like this, if you move like this, so whatever is coming, that is next. So this is first, second, third, fourth, okay. Any doubt? If you have any doubt, don't forget to mention that in the comment, okay. I will try to answer each and every one of you as much as possible, and if required we will make additional videos to explain whatever doubts you have. So don't worry, I am here to explain everything, and everything is free here in this channel. Every content that you are seeing is free, absolutely free, okay. Now, so first quadrant, what happens in first quadrant? In first quadrant everything is positive, everything is positive. All the ratios that you have studied, sine, cos, tan, even their inverses are all, everything is positive. Now in the second quadrant when you come, only sine is positive, sine and cosec, okay, basically opposite of sine. When you come to third quadrant, only tan is positive, and when you come to fourth quadrant, cos is positive. Now how can we remember that? There are many mnemonics, everything, but the simplest way, all sine tan cos. If you can remember this, all sine tan cos, all sine tan cos, all sine tan cos. So all sine tan cos. You just need to remember, don't waste your time remembering difficult mnemonics. If you can remember this using simple words, all sine tan cos, that's how I remembered, okay, all sine tan cos. So all means first quadrant, sine means next is second quadrant, tan is third quadrant, cos is fourth quadrant. So basically what is the meaning of that? If you take any angle, okay, say theta here, and if you try to find angle sine theta, whatever value it will get, you will get it is positive. In fact, in first quadrant, whatever angle, maybe sine, cos, tan, cosec, sec, cot, everything will be positive. Now if you take another value here, another angle here, this angle is, and always we will measure the angle from the positive x axis, not this angle, not this angle, it will be always this angle only. So let me clarify that. This will be always this angle only, this angle only, this is our theta, always this will be our angle theta. Okay. Now if you measure now, what will happen? Sin theta will be positive and rest everything will be everything. So cos theta will be negative, tan theta will be negative, any reverse inverse will be negative except cosec. Okay. So when you are going to second quadrant, only sin theta, for this value only sin theta will be positive. Okay. Only sin theta will be positive. Similarly, when you come to third quadrant, now you take another angle. Okay, you take another angle here and say this angle is another theta. So I am using different color code, I am not changing the name, I am using different colors so that you can understand. In this case, only tan theta will be positive, only tan theta will be positive, else every other angle, sin theta will be negative here, cos theta will be negative here. Okay. So first is all, here will be only sin, here will be only tan, and last will be only cos. So you understood the problem, understood the nature of the question. So here only cos theta's value will be positive. Between this, starting from here till here, only cos is positive, whatever angle. So basically 270 to 360, cos is positive. Okay, 180 to 270, tan is positive, 90 to 180, sin is positive, 0 to 90, everything is positive. So if you try to find the values, okay, we have remembered the table, remember 0, 30, 45, 60, 90. So only for this we have calculated. How can we find the values for this? So we don't need to remember values for everything, we can just, that first table is sufficient. Only you need to remember the signs. If you remember the signs, correspondingly you can calculate the values for sin cos in anywhere along this quadrants. That's why it is very important. Any angle can be calculated because we can just rotate the angle and find the final angle and then we can calculate. Okay. Now there are few identities that you have to remember. So sin pi by 2 minus theta. What is the meaning of that? Suppose I have this angle is theta. Okay. And pi by 2 minus theta is this angle, pi by 2 minus theta. Okay. So if you want to find sine of this angle, then you have to find cos of this angle. So basically they are complementary angles. In case of complementary angle, sine pi by 2 minus theta is just cos theta. Okay, cos of pi by 2 minus theta is sin theta, tan pi by 2 minus theta is cot theta. Now can you tell me what will be the value for say sin pi by 2 plus theta and cos pi by 2 plus theta and tan pi by 2 plus theta? Can you tell me the values? What will be the values? So sin pi by 2 plus theta, pi by 2 means here pi by 2 plus theta, right? So basically this angle is theta, this is pi by 2. So what will be the value? Sin is positive, so it will be cos theta. Okay, cos pi by 2 theta will be minus sin theta and tan pi by 2 plus theta is minus cot theta. Why? Because in this quadrant only value for sin is positive. Okay, so sin pi by 2 plus theta is positive, whereas cos pi by 2 plus theta is negative, because cos, we are starting with cos. Some people confuse with first value positive or second value positive. No, first value, you only consider whatever you are starting with, rest of the value can be adjusted accordingly. Okay, there is one more identity, sin pi minus theta. Sin pi minus theta. What is the meaning of pi minus theta? Pi minus theta means this angle is pi by 2, this angle is pi, right? So pi minus theta is this angle. So you have to take this angle as theta. So this angle is pi minus theta. Okay. This angle is pi minus theta. So pi minus theta means we are still in the second quadrant. In second quadrant, sign will be positive. Okay. Now remember what is the difference if it is pi by 2? If it is pi by 2, it changes, sine to cos, cos to sine, tan to cot. But if it is pi, it does not change. Sine remains sine, cos remains cos, tan remains cot, tan becomes cot, but with a catch. What is the catch? Catch is the sign changes. Okay, sign changes. This will be tan theta. Okay, but sign changes because in the second quadrant what will happen? Sign remains positive, cos becomes negative, tan becomes negative, right? But they remains identity remains same. Next is another identity, sin 2 pi plus theta. So sin 2 pi plus theta. What is the meaning of 2 pi plus theta? So you starting here, you are coming here. This is 2 pi. Then you are going to another angle theta. So basically 2 pi plus theta means same angle, angle theta, nothing else. 2 pi plus theta is the same angle theta. So sin theta will remain sin theta, cos theta will remain cos theta, tan theta will remain tan theta. Okay. Next. So if you have liked our video so far, don't forget to click on subscribe button and hit the thumbs up icon, and whatever comments you have, mention in the comment below. We will try to answer each and every one of you. So we will see you in the upcoming part 2 video. Thank you.